Okay, now we're going to put those kinematics to use. So using the kinematics. And how are we going to use these kinematics? We're going to use them with projectile motion. Alright, projectile motion. So what is a projectile? Well, a projectile is anything that flies through the air. It can have several different paths. It can look like this and take this path. It can be shot straight forward off of maybe like a cliff or something where we go down. It can be shot off of a cliff and go down. So we have these different looks of what this is like. Okay? Now, the first thing that I'm going to do when I do a projectile is, when doing a projectile problem, if I can spell, first find your initial velocities. Okay, so you have some options here. Okay, if it's shot like this, we're going to kind of show, I'm going to show each option here. If I'm shot like this, I'm at an angle theta. I have to separate those into two things. I have to find Vx naught and I have to find Vy naught. And both of those, if I'm shot with some velocity V naught, this one will be V naught. It's adjacent to, so it's going to be V naught cosine of the angle. Vy naught will be V naught sine of the angle. On this one, since we're shot straight forward, so a horizontal launch, the Vx naught is going to be V naught. The Vy naught is going to be 0 because I'm not shot upward or downward, I'm only shot forward. And then this one, I'm going to be shot like this. And it's going to be the same thing. This is going to be Vx naught, which is going to be V naught cosine of the angle. And this is Vy naught, which will be V naught sine of the angle. Now, it's exactly like this one. The only thing you have to pay attention to is this one is a downward angle. So I would always make sure that I enter my angle as a negative, or if I enter it as a positive, make sure to put that negative sign on the y velocity, because your x velocity is going to be positive. It doesn't care whether I'm above or below the axis, but the y does. So be careful of that, because if you do that, if you get this mixed up and you treat it as a positive, it's going to change your outcome. So you want to make sure that you keep those correct. These are positive positive, this is positive 0, this is positive negative. So make sure that you keep those straight. Okay, once you launch it, you're going to keep your variables separate. Okay, don't mix x and y. Okay, that's a no-go. Okay, now generally when you do a projectile motion problem, and I think I can almost say, instead of saying generally, it's kind of like always, because once you, if you have air resistance, generally projectile problems don't involve air resistance. And when I say generally, like, I don't know when they wouldn't on an AP test, because if they involve air resistance, then the kinematics are out the window. And the reason the kinematics are out the window is because air resistance is not a constant force. So it would not provide a constant acceleration. And if that was the case, you couldn't use kinematics because you would not have constant acceleration. So the kinematics would be out. So generally projectile problems don't involve air resistance. Okay, so this means that your acceleration in the x direction is 0. Okay, that's lovely when you're doing this stuff. And your acceleration in the y is going to be negative g. Okay, or negative 9.8. If you want to put 9.8 in there, depending on what you're dealing with, and you know, if you're using it in terms of variables or you're using it in terms of numbers. So let's look at an example. Let's just do an example of this. Okay, let's say that I shoot a projectile at a theta of, let's shoot it at 30 degrees. Okay, and I'm going to shoot that said projectile at 50 meters per second. Okay, so my first thing I'm going to do is I'm going to find my Vx naught, which is going to be 50 cosine 30, and this is going to be my Vy naught, which is going to be 50 sine 30. This one's going to be 25. This one is going to be 50 squared, it's going to be 25 squared root of 3, but I got to do the math on that. So 50 cosine 30. My calculator doesn't want to do this. Hold on, I've got to change my mode. There we go. My calculator's being fussy. So always make sure you're in the right mode, whether it be degrees or radians. Okay, and so I get 43 meters per second. So I have my Vx and my Vy naught. You need to do that in the beginning, okay? Unless you're doing it in terms of variables, you need to do these and you need to get numbers. Now I can find lots of things with this, okay? If it lands at the same height, what is my time of flight? Time of flight is something that we have to do a lot with projectile motion. So what is its time of flight? So we know that it's going to launch like this, it's going to go over, and it's going to land over here. And so we know that our delta y is going to be 0, because I'm going to start from here, I'm going to go up. I don't know why I look like I finished right there. I'm going to finish over here. Okay, I start from here, I go up, I come down, I land at the same height. So my change in my y position is 0. So to find my time of flight, many times my time of flight is found with the y version of the second kinematic. Now you notice this is going to look more like what you're going to see on the AP test because I've got subscripts on it. My delta y is, you know, how much it changes, which is 0. My Vy naught, I go to my stuff and I said that was 25 times t plus 1/2 times my acceleration, which my acceleration in the y is negative 9.8. Okay, now that's on Earth. Okay, it's not going to be that on some other planet. You're going to put whatever planet it is that you're dealing with. So I get 0 is equal to 25t minus 4.9 t squared. I'm going to add this 4.9 to the other side. So plus 4.9 t squared. I get 4.9 t squared is equal to 25t. Okay, obviously this happens at, you could do this way. You could say 4.9t times t is equal to 25t. There is one condition that would make this true, and that would be if t were 0. Obviously I'm at position 0 at 0. So that's what I'm doing when I'm canceling this out. I'm taking that first deal out. There is 2 solutions to this equation. One of them just happens to be 0. So then I get this, and then I divide by 4.9. And I find that my time of flight is 5.1 seconds. So there's my time of flight. All right, another question that you could be asked about this is, how far did it go? How far did my little projectile fly? When they say how far did it go, they're talking about delta x. What is delta x? The second kinematic is your best friend when it comes to projectiles. So delta x is v naught t, vx naught t, plus 1/2 ax t squared. So delta x is my vx naught, which I found to be 43, times my time of 5.1, plus 1/2 times my acceleration of the x, which is 0 because we don't have air resistance. So this term falls out. And you can get really used to just crossing this out, like in the end. I just don't like to write it that way because I don't want you guys to think that, you know, it's not there. It's there. It's just that acceleration is 0. So then I do 43 times 5.1, and I find that my delta x is 219 meters. And so that's how far my projectile will go. A lot of times when I give tests, I like to do this, and I have a king shooting at a castle, shooting his trebuchet at a castle or catapult, whichever you want to use. How far will it go? And if that castle is within that range, like if it's 219 meters or less away from it, then it can hit the castle. Okay, let's take this a little bit farther, and let's do a little bit more from this, because there is more that we can ask from this. So I'm going to kind of bump this up to where we can still see that, but we can see my new stuff here. Okay, what if I asked you, what is the max height? Okay, so say I'm shooting this in a basketball gym, and I want to make sure that I don't hit the ceiling. What is the max height the projectile will go? Well, with this, we have to look at, I'm going to kind of bump this over here just a minute. We look at what's going on with the projectile velocity as it goes across like this. And what happens is we have an x velocity and we have a y velocity. And I'm going to do this in pink and I think green, maybe purple, that might stand out. Okay, my Vx is the same all the way through. Vx never changes. All the way through, Vx does not change. Why? Because there's no acceleration in the x. But Vy changes. Okay? In the beginning, my Vy is big. Okay? Because I'm trying to get up here to match this, what would be the velocity vector. But what happens to my Vy? Notice my arrow, it's getting shorter and shorter and shorter. But at the very top, my Vy is 0. Because at the top, if I throw something straight up, this makes more sense. We can think of that. If I throw something straight up, it's going to go up, 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 up until it stops. And then it's going to turn around and go down, 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 down. But when we shoot it forward, a lot of times my students get confused and they don't realize that there is no y velocity up there. But there is. There's no y velocity at the top. It's all x, all forward. As I start to go down, what happens to my y velocity? It starts to get a little bit bigger and a little bit bigger and a little bit bigger all the way down. My velocity in the y increases. Why is that? Because I have that acceleration. Remember, my acceleration in the y is g, and it's downward. Okay, it's always downward. So imagine it like a weight pulling on it. We start off going fast, but we slow down, stop, and then we speed up, speed up, speed up as we're coming down. So we have that motion. So at max height, when I ask what is the max height that it'll go to, at max height, my Vy final is 0. So when I'm asking for max height, I'm asking for delta y. What is delta y? So delta y, V final, we know Vy naught, it's 25, and we know Ay is negative 9.8. So if I go look at those kinematic equations, if I look at that list, these variables all occur in the third kinematic. I do not have time. I have those variables. So I plug these in. Vy final, that's 0. Vy naught, that's 25. Acceleration is negative 9.8. Delta y is what I'm looking for. So I get 0 is equal to 625 minus 19.6 delta y. I'm going to add that 19.6 delta y to both sides. I get 19.6 delta y is equal to 625. I divide by 19.6, and I find my delta y is, drum roll please, 31.9 meters. And so that's my max height of my projectile. Now, does this cover everything you could ever encounter in projectile motion? No. But does it give you a good start? Yes.